And just when you thought we were done with our last video, there's one more. Okay, so today we're going to talk about creating a cumulative frequency graph. It's also known as an ogive. It's kind of a weird name, but there you go. So the first thing we're going to do is we're going to look at this data table. I have number of hours. In my first row I have 0 to 2, then 2 to 4, 4 to 6, 6 to 8, 8 to 10, and 10 to 12. And then I have a frequency. So I have 10, 15, 30, 35, 25, and 5. That means that 120 children used computers last week. They took the data on that. And 10 of them used computers from 0 to 2 hours, 15 from 2 to 4, 30 children used computers for 4 to 6 hours, and so on. And we want to find the mean. Well, if we only had individual data points, we'd add them all up and divide by the number of data points we had. But that's not what we have. So we actually can only get an estimate of the mean because we don't know exactly how many hours each of these 10 children used the computer. We have to estimate that. So we do that by taking the midpoint of our interval here. So halfway between 0 and 2, I'm going to make a new column for that. That's my midpoint. That's going to be 1. And halfway between 2 and 4 is 3. And if you need a formula for that, you add the data values together and divide by 2. Halfway between 4 and 6 is 5, because 4 and 6 are 10. Divided by 2 is 5. And then 7, 9, and 11. So for the mean, since we have 10 values that we're estimating to be 1, instead of adding 1 up 10 times, we're going to do 10 times 1. And then instead of having 15 data points and adding all 15 of them, the data values are 3, we're going to multiply instead to make our formula shorter. So 15 times 3 plus 30 times 5. 30 students or children used the computer for 5 hours last week. And 35 children used computers for 7 hours last week. And 25 for 9 hours. And then 5 for 11 hours. So I have what would normally be in the numerator. I still have to divide by the number of children I have. So I'm going to take this sum here, add it up, and divide by 120 because that's how many values I have. So when I calculate that, I end up with 6.08 as my mean. And that's how you calculate a mean when you have grouped data, like we do here. All right, so the next thing we're going to do is, as soon as I figure out how to shrink this down and move it, okay, is we're going to make a cumulative frequency table. So I have over here the number of hours again, and instead of frequency, you'll notice that it says cumulative frequency. When you hear the word cumulative, you can think of accumulation. That's sort of like cumulative. And what you do to get the cumulative frequency is, so from 0 to 2 hours, I have 10 children. From 0 to 4, from the last table, I have 15. So it's going to be 10 plus 15, because so far, up to 4 hours, I have 25. Okay. And then from 0 to 6, I have an additional 30 children, so 25 plus 30 is going to give me 55. What I'm doing is I'm taking my last value that I had, and I'm adding it to the next value. So then for this one, I have 35 more. I'm accumulated. And that gives me a total of 90. And then for this one, I have 25 more I've accumulated. And that gives me a total of 115 of my children have used the computer up to 10 hours. And then the last one is my last 5. And that gives me a total of 120. And the thing about this is you need to end up with the same amount here that you have in the problem. You have to have 100% of them when you do the cumulative frequency at the end. What we're going to do with that is we're going to make a cumulative frequency graph. So you're going to need a ruler for this. I don't have one on this, so it's going to be a little bit sloppy, but you will need a ruler. Okay, so since our data table starts from 0 to 2, along the bottom here, along this axis, that is the number of hours, and along the side here, that is the frequency, or the cumulative frequency, not the frequency. So since I have a value of 0, that's where my graph is going to start. If my starting value was 2 to 4 and not 0 to 2, then I would start at 2 like this, but that's not what I have here. So let's get rid of that. Okay. So then the upper end of my interval is 2, and by the time I get to 2, if you look at the table, I have 10 in my cumulative frequency column. So then, if I look down at the next interval, I have 4. That's the top of the interval, and I have 25 by the time students by the time I get to that interval. So I need to figure out where 25 is. That's going to be about here. And then the top of the next interval is 6. So at that point, my cumulative frequency is 55. So I have to go and find 55. So that'll be here. And then the top of the next interval is 8. And when I get to 8, I have 90 as my cumulative frequency. So I'm going to plot that point. And when I get to 10, I have 115 as my cumulative frequency. So I'm going to plot a point at 10, 115. And finally, when I get to 12, I have 120. And here's where the ruler's going to come in. And one of the places the ruler will come in handy. Ooh, I wish I had a straight line drawer. You're going to connect these with a straight line. I know we're used to drawing curves. This time we want straight lines. And hopefully your straight lines are better than mine. Okay, so that's what a cumulative frequency graph looks like. It's pretty easy to make. What can I do with a cumulative frequency graph? Well, we're going to find the quartiles from our graph. So let's go back up here for a minute and look at our frequency table. If I have 120 pieces of data, if you remember finding the median back in middle school, you're looking for the middle of your data. And normally, if I have an even number of data, it would be the data value. You would add 1 to the data value and divide by 2. So in this case, it'd be 61.5, which would mean your median would be between 61.5. I mean, it'd be it'd be the average between the 60th and the 61st value. And that would divide both sides of your data into 60 pieces. Since our cumulative frequency graph is an estimate anyways, because remember, we're taking the midpoints of these, it's an estimate, we're just going to take the halfway between 120. So in this case, if you look here, that would be the 60th piece of data. Our median is at 60. I just have to get my graph back up here. There we go. Okay, so how do I find the value at 60? Okay. Again, you're going to need a ruler, and if you have this on a quiz or a test, or when you have this on a quiz or a test, you will need to draw this in and show your work. Oh, I want to scooch this over just a little bit. There we go. Okay. So halfway between 0 and 120 is roughly 60. So you take your ruler and you draw a dotted or a dashed line over to the point where the graph is, or there's a value on the graph, and then you draw a line down to the other axis. And you can see that that value is about, it's less than 7, because 7 is here, and it's less than 6.5, so I would say about 6.4. Oops, not quarter one. This is Q2, or the median. Median is also called Q2, second quartile. So it's about 6.4. So if I want to break this, quartile means quarters, I want to break this data into quarters. Halfway between 60 and 0 is going to be quarter 1. So again, I'm going to draw a dashed line over and then down. And that is about 4.4. So that means that 25% of students or children are using the computer less than 4.4 hours. So if I want to find the third quarter, I have to break the data values between 60 and 120 in half, and that's going to be at 90. That's halfway between the two. And I'm going to draw a dashed line over to here, and then where it intersects the graph, I'm going to draw a dashed line down. So that is at about 8 hours. So 100% of our 120 use the computer less than 12 hours, 75% use it less than 8, 50% less than 6.4, and 25% less than 4.4. Let's say I wanted to find the 90th percentile. That's the value at which 90% of the values are less than. So I would do 90%, or in decimal, times the number of data values. And 90% of 120 is roughly 108. So if I go up to my graph, 108 is here. Draw a line over and down. That's a sloppier line because I'm getting tired. then 90th percentile is at, so the 90th percentile is at roughly 9.3 hours. Cumulative frequency stuff. This stuff's pretty easy, right? So let's look at something called a 5-number summary. That consists of your minimum value. It also consists of Q1, your median, and Q3, and your maximum value. So there are 5 numbers here. In this case, it's going to be 0. That's our minimum value here. Q1 was 4.4. Our median was 6.4. Q3 was 8. And our maximum value was 12. These are the values I need to make a box and whisker plot. So to make a box and whisker plot, it's really nice if you have a cumulative frequency graph because you can line it up right underneath it. And the min and max are where my whiskers of my box and whisker plot go. And then I have a box around Q1 to Q3. And then oh, that's not Q3, sorry. That's my 90th percentile. Get out of there. Okay, so a box around my quartiles, and then a line down the middle for my median. So a box and whisker plot has a box around your inner quartile, and that represents the middle 50% of your data. And then each end is the min and the max, and the median has a line down the middle. I'm going to make up some data and show you how to find the 5-number summary. Let's say I have test scores, and we have a 40 because Johnny didn't study, a 65 because Mary studied but got a concussion and forgot everything. And then we have 2 70s, an 80, an 85, 1, 2, 3, 4, 5, 6. Let's go with a 90 and a 95. All right, I want a 5-number summary for this, and then I'm going to make a box and whisker plot out of this. So remember, I need my min, my Q1, my median, my Q3. Median's also called Q2 sometimes, and I also need my maximum value. All right, so I need to break this data in half. I have 8 pieces, so 8 plus 1 divided by 2 is 4.5. That means my data value is halfway between the 4th and the 5th data value. You'll notice that I lined all these up in order ahead of time. I need to do that. All right, so halfway between 70 and 80 is 75. That's my median. If I just took this 4th value, because that's halfway between 8, that's like the middle of 8, then I'm taking this value, and you'd see that I only have 3 data points on to the left and 4 to the right. That's not really breaking my data in half. That's why I have to add 1. Oh, come on. Cooperate. Thank you. All right, that's why I have to add 1 to find the middle. If I had an odd number of data points, I could just take that middle value, because then, let's say I had 9 pieces of data, I had another like 75 in here, I could just take that one and it would be the middle. But since I don't, I have to split it in half. All right, I have to do the same thing for Q1. I have 4 pieces of data over here on this side. Looks like my pen's starting to die. So halfway between the bottom and the middle, if I take this, I'm going to take the average between 65 and 70, which is 67.5. And then same thing up here, because I have an even number of data points, I need to find the middle. If I had an odd number, I could just take the middle piece and not take the average, but I don't. So that's going to be 87.5. And then my min is 40 and my max is 95. So nice when I get to that point. All right, box and whisker. Key to a box and whisker plot is you need to have a nice drawn scale at the bottom. You'll notice I'm trying to keep this nice and even, because if you distort it, it doesn't mean anything. Your box and whisker isn't going to be very good. You're not going to be able to tell anything about it. Okay, so my whiskers are going to go to my min and my max, and my minimum is 40, my maximum is 95, so halfway. The box goes around 67.5, so I'm going to say that's here to 87.5. I'm going to call that 87.5, and then the median is 75, so that's halfway between 70 and 80. And that's my box and whisker plot. So this right here, Q3 minus Q1, this box right here, that's called an inner quartile range. For short, because mathematicians like to abbreviate things or make up weird symbols, we call it the IQR. If I wanted to see if I had any outliers, any unusually high or low values, so for outliers, I could have unusually low outliers, so something really low like a 0 would probably be an outlier. But there's actually a mathematical test for that. So lower value outliers we call that a lower fence. Any value that's lower than this fence is we can outcast it if we want to. So that is going to be equal to 1.5 times the IQ, inner quartile range. Oh, it's Q1 minus 1.5 times the inner quartile range. My inner quartile range in this case is 87.5 minus 67.5, so that's going to be 20. So let's actually calculate and see if we have any outliers. Q1 is 67.5 minus 1.5 times my inner quartile range, we said that was 20. So 67.5 minus 30 gives me 37.5. So anything lower than 37.5 would be an outlier. We don't have anything lower. We have 40, which is close, but it's not quite an outlier. So we could have things that are too high as well. So those would be up in this end. I can see that we don't, but let's run a test and see how high a score would have to be. So instead of Q1 minus 1.5 times the inner quartile range, it's going to be Q3 plus 1.5 times the inner quartile range. Q3 is 87.5, and this time it's plus 30. So we'd have to have a score of 100, 111? No, 110.5. Sure, we'll go 117.5. We'll go with that. Close enough. but you can see we don't have that. So that's the basics about finding a box and whisker plot and creating a cumulative frequency graph. Things we do with box and whisker plots, we don't usually look at them on their own. We usually compare them with other box and whisker plots. And we'll do more of that later in class. So on the next slide, I have a picture of my completed notes scanned in, so you can take a look at that and compare it with yours and make sure you have all the information you need. There you go, and good luck. Complete the classwork, please, in case you have a quiz on this next class. And then you can start your review packet for homework. I do not expect it all to be done. You have lots of time to review, so just do a little bit of it and come to the next class with questions if you have them. We'll see you Friday.